that one sheet of paper that I could hand to my fellow security engineer and tell him, that's all I have understood from the process control engineer, and now we need to secure it. We don't have that.
Welcome everybody to the Industrial Security Podcast. My name is Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Sarah Fluchs. She is the Head of Security Engineering at Admeritia. She's going to be talking to us about some work that Admeritia is doing, that she's been doing at Admeritia, working with the engineering community to define a new approach for security engineering.
Okay, here's you and Sarah.
Hello, Sarah, and thank you for joining us. You're talking to us about problems and approaches to security engineering. Can you start at the beginning? Where does it all start? What is security engineering, and what's the problem with it?
You know what's strange? If you have an automation engineer, they love to build things, they know their systems really well. And if you go to an automation engineer to talk about the systems, he's like, I know these things, don't mess with my systems. But if you go to an automation engineer and talk to him about security, he's like, oh, well, these are my systems, please make them secure. So they're taking a passive part in that. And during the last years, always when a new automation technology was raised or something was raised, there was always someone stepping up saying, have you thought about security? And the thing is, automation engineers do want to tackle that. They do want to think about security, but mostly they're just looking back at you and say, well, I would love to, but tell me how. How do we do that?
So if that's the problem, how do we address it? What's the right way to go forward?
Well, we at Admeritia, we are consultants. So engineers come to us if they have a problem concerning security. And our role really is enablement. So we want to empower them to take responsibility for their own system security. We want to lead them to the how. We want to teach them how. And because that's our role, we, of course, had to develop methods and models and ways in order to do security, but from the engineer's perspective, because the engineers are the ones knocking on our doors and wanted to know how to do security.
So, Nate, let me jump in real quick here. Admeritia is a German company, and what we're talking about here is engineering. And, there is the reputation the Germans have for, outstanding engineering. The sense I got in talking to Sarah here was that Admeritia is, deeply embedded in the German engineering culture. They're a consultant to engineers. And, what she's talking about here is what they're observing in the engineers that come to them. She's basically saying, look, there's a gap. Engineers want to do the right thing security-wise, and they simply don't know how. There really isn't a discipline of security engineering that is anywhere near mature, and Admeritia is working with the German engineering community and other engineering communities to develop that security engineering methodology, that discipline, to the point where it is mature in the sense that all of the other engineering disciplines are mature in terms of their problem-solving methodology.
So when an engineer or an engineering team comes to you folks and says, I have this problem, where do you start? How does it work?
So at last year's S4, I think I presented a model which was more or less a thought model, a procedure model, how to do security engineering. It's not rocket science. It's more or less a meta model that we created in order to fit in all the existing procedure models that are there, just to compare them, to show their commonalities and the differences, and to build something that leads our clients, leads the engineers through the security engineering process. Because it's not that hard. What it boils down to is more or less you have 4 layers that you need to go through, 4 steps you need to go through. Of course, you can make them more detailed, but the first is always you have the function layer. So you need to understand the function of the systems you want to secure. You need to understand what to secure. And the second one is risk. So you need to know what problems you have, what you want to secure against. So what the uncertainties are you're securing against, what the threats are, the vulnerabilities are, what the problem is you're solving. And then third, you've got the requirements layer, which is basically there in order to, which is a very engineering kind of approach, separate requirements from the implementation, which is the fourth layer is the implementation layer. So we've got third, the security requirements, which nail down how you want to solve the problem that you described in the function and risk layer. And then you've got the implementation layer, which basically describes how you want to implement a solution, but and in the end, what technology you need to use to implement that security solution or that set of solutions, because it's not always just technical solutions, obviously. So I don't think I'm going to explain all that model in detail, because there's a paper about it and you can watch the S4 talk. So that's not the material of the podcast today.
Can I clarify your comment on risk? I mean, some people think risk is a list of all of the software vulnerabilities. Other people think risk is an understanding of which bad guys are coming after us and how they're coming after us. There's a lot of pieces to it. What is your view on, how do you see risk?
So for us, that's the reason I said threats or vulnerabilities or anything, because risk really can be anything, and the entire idea of that procedure model is to be as neutral as possible. So any method how you would identify risk, be it threat modeling or be it even threat intelligence or be it penetration tests and finding vulnerabilities and software vulnerabilities, all that would be sensible methods for identifying risk. And all these you put together in that procedure model. And that's why this procedure model exists, because you need something neutral and you need to have the possibility to interchange methods on each step.
Andrew, these 4 steps sound pretty straightforward, pretty intuitive to me thus far.
It does sound fairly straightforward, but, my recollection of the interview was that it gets very complicated later on. Maybe the missing piece, what I didn't get when, during the interview, is that, the approach that Sarah's described here is, as far as I know, basic engineering. I'm not an engineer. It means, understand what you have, understand the problem you're trying to solve, understand, determine what are the requirements for solving the problem and select a solution. It's basic engineering. I think what made it difficult for me when I was going through this was that I didn't understand that what Sarah's talking about is not redesigning any one of these steps. She's going to be talking about redesigning the connection between these steps. And, maybe that little nugget is something that's going to make the rest of the conversation easier to understand than I did the first time.
So in your 4 layers, function, risk, requirements, implementation, it all starts with function. How do you start? How do you do that?
So the function layer is actually the most important part of it, and it's also the most time-consuming part, because you have to understand a lot of information that's already been there, that's been created by different disciplines. And we really don't have, for security, what we don't have is a concise model, a system model that contains in an easy to communicate way all the information that you need in order to secure a system. And that's the most basic thing you need in order to secure systems. That's your basis, your fundament for security engineering. So maybe it works with this analogy. So what we need is something like a P&I diagram for security. So a piping and instrumentation diagram for security. Because piping and instrumentation diagrams, if you look closer at them, they are there because process engineers need to model how their plants work. So there's the piping, there's sensors, there's actuators. You quickly grasp when you look at the P&I diagram what the entire plant is about. And then there's also a part which is called PCE requests, which tells control engineers, PCE requests, because it's called process control engineer requests, or engineering requests. these requests tell the process control engineers all information they need to know in addition to the process engineering part in order to design, to engineer their control systems.
Can you give me an example of what one of those PCE requests would look like?
They are basically a request for, you're going to request for a control loop. So there's a control loop, for example, the PCE request tells you need to control pressure here, or you need to control temperature at that part. And you have a certain alarm that goes off when the temperature rises to a high point, for example. So that could all be information that's in these PCE requests. And the important part of the P&I diagram is that it separates functionality and technology. So it says, I need a pump functionality, but it doesn't tell you which kind of pump you need. That would be the engineering then. So in a way, the P&I diagram is the interface between the physical world and the control system world, the electronical world. And also it's the interface between two engineering disciplines. It's the interface between process design engineering and process control engineering. And in a way, process control engineering is a kind of auxiliary discipline for process engineering, because if it wouldn't be for the process, you wouldn't need any control engineering. Automation is just there to make the process, that is the main purpose you have, more efficient, to automate it. So in order to do automation and to do control system engineering, you need to understand very well what the process you're automating is about. And in a way, that's very similar with security, because now we're taking the next layer. The process engineers, process control engineers designed their control systems, and we as the security engineers are just an auxiliary discipline for these process control engineers, because there would be no necessity for our discipline if we wouldn't have control systems. There would be no need for control system security without control systems. It's easy. And so you can't really do control system security well without really well understanding the control systems. And so we also need an interface like the P&I diagram is for process engineers to process control engineers. We need an interface from process control engineers to security engineers, because we are just in the auxiliary discipline for the process control engineers.
Andrew, you said a moment ago that this interview was going to get a bit complicated. I believe you now.
Okay, yeah. So let me dive into it. Again, I found the Sarah mentioned a recording, a video on S4. I found that very useful. I went through it, and I'm gonna go through some of these concepts. My apologies to the process engineers in our audience, because I'm probably going to butcher some of these concepts, but I hope to get enough across that we'll be able to make sense of things. Sarah just used an analogy. This is the piping and instrumentation diagram. This is something that comes out of process engineering, process industries. In the process industries, we're manipulating things that are kind of like fluids. Think a hydro plant where you've got water coming through turbines, turning the turbine to produce electricity, or a refinery where you have unprocessed oil going into a catalytic cracker, getting heated up, getting transformed into other substances that are siphoned off at different levels of the cracker. So in these process industries, in those examples, there's piping. Okay, the material being produced is a fluid. Pipes are carrying the fluid. The process engineers are the chemical engineers, or the fluid mechanical engineers, and they are designing the piping. And they're designing the physical process, be it the turbine or the chemical processes. And so there's a standard sort of diagram that these folks use to say, here is what piping looks like for the entire refinery, drill down into each of these pieces, and there's nested piping diagrams that go all the way through explaining how the entire thing looks. And they annotate these diagrams with required instrumentation. So they'll say, I need this tank kept at between 10 and 13% of full on the bottom, so I have lots of room on the top for the gases to evaporate because I'm heating the bottom. And, I need it kept at this temperature and that pressure and this level. And they annotate the piping diagrams to say what is needed of the control, the process control functions. So this diagram is produced by the process engineers because they understand what they need in the physical process. And they hand it off to the control engineers. The control engineers are the ones that understand how to design control systems. They understand PLCs and historians and HMIs. They understand how to produce procedures for the operators to use everything they produce in terms of software. They're focused a lot on the software end of control systems, and they use this the piping and instrumentation diagram to design the control system. And what Sarah is saying is that, look, in the security engineering world, we have a problem. We don't have anything analogous to a piping and instrumentation diagram. That diagram is the interface between the process engineer and the control engineer. What we need is a similar convention, a similar way to describe the problem as the interface between the control engineer, who understands the control system, and the security engineer, who needs to design the security system for the control system. That piece of the puzzle, the connection, the way to communicate between the control engineer and the security engineer is the missing link. And this is what she's going to be talking about for the rest of the interview.
So this begs the question, if the P&I diagram for security engineers does not exist, how do you do your work? Are you inventing this as you go?
So that's really the strange thing is it doesn't really exist so far. I have no clue how other people do security engineering, because when we come to a site and we need to understand quickly what the functions, the most essential functions of a plant are, maybe it's just me as an engineer, but I want something like a model, want a sheet of paper where I can put all this information. So that one sheet of paper that I could hand to my fellow security engineer and tell him, that's all I have understood from the process control engineer, and now we need to secure it. We don't have that. So we actually trying to develop something like this. It's not that easy because security engineering is not just about technology. So it's not done with PCE requests which contain pressure and target pressure and things like that. But it's also people business. So you always have to incorporate in your model in a way organizational processes and human roles, things people are doing, and also, of course, technology. So functions of systems you have and communication between these systems you have. And we actually start building these models based on what we call use cases. So there's person A, which does something with system B, and system B communicates with protocol C with system D. And that's how we try to build these system models for security engineering. So the interface between the process control engineering and the security engineering. And it's really important to have the process control engineers in these sessions because they're the only ones that can give you this information. And we're actually doing that right now, and during that process we create hundreds of visual sheets that are not really easily maintainable. They're not as standardized as something we have in a P&I diagram. The beauty in the P&I diagram is that it's highly standardized, but it's standardized in a visual way that's easily human readable. So it's intuitive to read, and you can quickly grasp all the relevant information out of it if you look at it, if you know how to read it.
Waterfall Security Solutions is the OT security company, and we are pleased to announce a new white paper, Cybersecurity Imperatives for Vital Rail Networks at Operation Control Centers. Strong cybersecurity is a prerequisite for safe, reliable, and efficient railway operations. Waterfall's unidirectional security gateways provide hardware-based protection for signaling, train safety, energy management, and other vital networks. The gateways replicate critical systems, devices, and protocols to external networks unidirectionally. Those replicas provide safe access to Operations Control Center data. To download the white paper, please visit waterfall-security.com and look for Rails under the Industries menu.
It sounds to me like Sarah's talking about diagrams, something that we already kind of do in the industry. What's unique about this particular methodology, Andrew?
The tricky bit here is that, partly that there's no standard. And partly because there's no standard, people are all over the place. So let's talk, the function, the first step is define the functions of the control system. And Sarah's identified that there's two parts in the function. There's the networks and the network diagrams, and there's use cases. The network diagrams, there's confusion there. In her S4 presentation, she pointed out that a lot of people confuse network diagrams with wiring diagrams. Wiring diagrams are way too detailed. They don't show you the right thing. If you look at the ISA standards, which are also called the IEC 62443 standards, they talk about defining your networks as zones and conduits. So not every device with every wire that's running into a switch, but groups of devices that have similar functions, that have similar requirements, and the groups of devices talk to each other. So that element of it is reasonably well understood if you pick the right standard, if you know to do the right thing, which is to use an abstract representation of the network. And then you couple that, as she mentioned in her S4 video, with the use cases, which are scenarios, which are saying, okay, when I have the control system, I use it to do this, I use it to do that. And that leads, that understanding of the control system leads into the risk assessment and leads into the security requirements.
Okay, but I'm having a difficult time trying to picture what we're talking about. Andrew, have you seen one of these diagrams she's talking about? How do you represent this information in a diagram in the first place?
She did give some examples in some of the articles that actually she's published online. If you search for Sarah Fluchs and security engineering, you can find them. One of the diagrams I recall is a sort of a time series communications diagram saying, okay, the use case is the operator needs to be able to open a valve on the pipeline. Operators do this, many times each day. How does it work? Well, the operator uses the mouse to control the HMI software. The HMI software reaches across the network, reaches out of the HMI zone into the communications controller zone and instructs the communications controller to send a Modbus message to open the valve. The Modbus message goes out over the wide area network. And so the diagram looks like entities, person, HMI software, communications controller, RTU, and device, the valve. And there's arrows that go between these entities, and time is the vertical axis. So all of the arrows are sort of moving down because everything takes time to transmit. And there's communications between the human and the mouse and the keyboard and the HMI as an arrow, and between the HMI and the controller as an arrow. And these arrows go down, usually to the right, and then they come back, going back down to the left. It's a very simple scenario. More complex scenarios involve multiple entities simultaneously communicating, and you'll see this sort of tracing of messages back and forth with synchronization points where all the messages have to arrive before you can move on to the next one. And this is the example she gave of one way to think about a use case in terms of what does the control system actually do to achieve a certain function.
All right, so it sounds like they've got this stuff figured out.
Well, I think Sarah's point is that it's not figured out. They are figuring it out. They are working with engineering teams in one industry, in one enterprise, in another enterprise, and they're working on all of these pieces. And, they know it in their heads, or at least they know as much of it as they've seen. I think Sarah's point is that it's not standard. If you look at piping and instrumentation diagrams, there are standards for piping and instrumentation diagrams. They're all the same. Everybody who looks at one understands the standard can look at a diagram and understand what it means. There are no standards for this interface between control engineers and security engineers. And what that means is that everyone does it differently. Half the people don't even know how to do it. And, everyone else has no idea if what they're doing is complete. If you move to a new industry, do you need something else? Do you need use cases and network diagrams and something else? It's, until it's standard, until a lot of eyes have looked at it and everyone understands it, we don't have a security engineering discipline. What we have is individual practitioners out there trying to do the best they can, and some of them do better than others. Whereas when it's a discipline, you can see an entire industry, the entire population of engineers executing, to a clearly defined, minimal set of expectations. And right now, it's not standard.
If the job of security engineering right now means a lot of Visio diagrams, a lot, hundreds of these things, is there a better way going forward? Are you folks working on a better way?
Of course, there's a way more efficient way. I think everyone who's involved in any way digitalizing things and doing processes on computers would know the next step, which is obviously getting this in an electronic model. The thing is, you need a standardized paper model in order to do an electronic model, because P&I diagrams, if you take them as an example, they're easily human readable, but they're not that easily computer readable because they're not standardized enough. So there's a big step, and you first need to standardize what we now do in these Visio models in a way that you can also transfer it to a computer, make a computer understand. Because, of course, since we said security engineering is always a kind of auxiliary discipline for process control engineering, and we want process control engineers to be able to do it, it needs to be efficient, because they have to fit it into their daily routine somehow, into their daily engineering. And we cannot reinvent the wheel. We have to use whatever they use, and we have to make it as efficient as possible, and we have to make all the documentation we're creating, so the models we're creating, and the function layer model is only the first step. There's more to come. Then we need to do that in a way that's maintainable and that's reusable. And we need to find a way how to use all the information that that other engineering disciplines already produced. We need to leverage all that information that's already there instead of reinventing the wheel. So just take asset inventories. That's a very simple example. But of course, asset inventories, if they are available electronically, they're a really good basis for understanding what you have. And you wouldn't want to do that again, to collect all that information again. But in order to leverage electronic information you may have in different tools, you need a way to make your security engineering model so that P&I diagram kind of model where you put all the information you need for security engineering, you need to make that electronically available, because if it isn't, you can't leverage other information that's electronically available.
So it sounds like a complicated set of requirements. You folks are working with these requirements manually now. How does, what's the next step? How does security fit into this?
I think first and foremost, if you want to make security engineering efficient and you want to leverage other engineering disciplines' information, of course you need to make your own information electronically available. And other disciplines, you need to be able to digest other engineering disciplines' electronically available information. And because security engineering is always a kind of auxiliary discipline, we always have to work together with many other disciplines. We have to accept the fact that there will always be a lot of different tools for different disciplines which are not compatible. That won't change. And that, in fact, is not a problem that is in any way unique or new for control system engineers, because they've been living with that for ages. There are CAD tools, and there are PCE tools, and there are robotics engineering tools and kinematic tools, and they need to interchange the information between these tools, and they do that in exactly the way that they do the paper exchange as well. So they have the P&I diagram in order to have the human interface, human readable interface between different engineering disciplines. And they have neutral data exchange formats, one of which is automation XML or automation ML, in order to have the electronically available interface between different engineering formats. And there's a really big chance in leveraging all that information that we have in the control system engineering process. Just take safety engineering, functional safety engineering. They have a really systematic way of outlining consequences, like worst case consequences, high level consequences, high risk consequences, and modeling risk. And of course, that's not entirely the perspective we need for security engineering, but it's a great input for security engineering. We don't need to reinvent the wheel on how to find out the most vulnerable processes and the most vulnerable system components if safety engineering has done that already. So if you find a way to leverage all that information, then we could be just much more efficient, and security engineering could also be much more accepted amongst control system engineers, because it comes from within what they're doing. And also it gives them the chance to, what we said at the beginning, to take security for their control systems in their own hands. So do it from their perspective, with their tools, in their way of thinking, using their methods and enhancing their methods. But really the only way to exchange all that information efficiently in a standardized way is that we need a kind of model in order to get all the information in, and that would be the P&I diagram for security, the equivalent for that.
One more clarification. Sarah mentioned the interface to safety engineers. She's talked about network diagrams. She's talked about use cases. Talked about the timing diagrams for messaging as part of a use case. I just wanted to give one more example. We had James McGlone from Kinexus on the show talking about their security PHA review book that the ISA just published. And I just wanted to point out there is, yet another format for communication that is reasonably standard, and that's the process hazard analysis. And that's a table with columns like what is the deviation from normal that we're observing, what's the consequence of that deviation, a safety consequence, how severe is that consequence, what's the likelihood of that consequence. Columns like this, and they're talking about annotating that safety analysis with a column for the security requirements. So that's yet another piece of the puzzle that Sarah's talking about as part of the P&I diagram for security engineering. So it sounds like there's a lot of pieces to it, and there's probably the same pieces for reliability, possibly coming out of something like the CCE methodology that we had Andrew Bachman on talking about from Idaho National Labs. There's a lot of pieces in this puzzle that need to be put together into a standard, I think is the point she's making. So how far away are we from having this P&I style interface between the control engineers and the security engineers defined and, maybe even standardized?
We're working on it. And we know that we will never be able to do that alone. And it shouldn't be done by security consultants alone. We do need the control engineers in there. We actually started, applied for a research project doing that for the next year and coming years. And I also think most, like all the other models, the P&I diagram wasn't created overnight. It's standardized, and as we all know, standardization takes a long time. It's consensus based. And during that time, it gets pushed forward, it gets brought forward, but it also gets better, because control engineering is already a discipline that, has interfaces to many, many other engineering disciplines. And for security, I guess it's even worse. So we need to get so many different disciplines on one table. And that's why it's going to take some time.
So this has been really great, Sarah. We're coming up on the end of the episode. Did you want to sum up? Is there a thought you'd like to leave with our listeners?
So there's actually two thoughts. Start with the more general one. We've just been here at S4 this year again. And like most years, we've talked a lot about finding vulnerabilities, about knowing more about threat actors. And all that research is important. It's good that we have that. But we must not forget that after letting control engineers know that their systems are vulnerable, that their systems are insecure, we owe them then what? So we owe them an idea to how to secure the systems. And we owe them that not only for a single vulnerability. So this is a vulnerability, do this, and then it goes away. But we need to provide them with something more general. Do this, take these steps, and contribute to this kind of model. And then you're contributing to securing systems. So, and the more concrete point is, we're trying to build that model, that P&I diagram for security. With every project we're having as security consultants, we are enhancing it, but we can't do it alone, and we don't want to do it alone. It's not the right way that we as security consultants, we as a security community develop all this. We need control engineers and we need automation engineers to step up and contribute and tell us what information they need to go into that. We need to figure out what the entire automation engineering process looks like and where we can slip security into the earliest in order to make security by design possible. And in order to do all this, I can provide a first shot model. And I will over the next years, I will provide ideas how to start with that model. But I need you, and I need security engineers, and I need control system engineers to participate. And if you do have ideas, you're welcome to reach out.
Andrew, we mentioned earlier that if there's anything complicated about the interview that we just heard, Sarah's S4 talk clarifies a lot of these concepts. What is the title of the S4 talk? Where can we find it?
You can find the S4 talk on YouTube. The title is Layered Blueprints for OT Security. Layered Blueprints for OT Security. Search, if you go to Google and search for that and throw S4 into it, or, Sarah, if you get her name right, SARAH, Fluchs, FLUCHS, it should come up as the first hit.
Okay. Well, in that case, thanks to Sarah Fluchs for speaking with you, Andrew, and thank you, Andrew, as always, for speaking with me.
Always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.